Hello everyone. This video is all about DES key encryption. As we all know, DES stands for Data Encryption Standard, which uses a block cipher and encrypts data in blocks of size 64 bits each, which means 64 bits of plain text go as an input to the DES, which produces the 64 bits of ciphertext. So, as you're seeing, we are entire DES process is based upon this diagram. So whatever the input that we have given to the DES, that goes under the message block. So the 64 bits message will be undergoing the permutation and division process, and that permutated uh, value undergoes the 16 rounds, where each round is given with the subkey, where subkey is generated by taking input of 64-bit key and undergoing the permutation, it generates a 56-bit key. So after undergoing the 16 rounds, it undergoes the final permutation and the ciphertext is generated. So let me explain you the entire process of DES key encryption with the following code. Here, coming to the main function, we are inputting a string that is plain text of 64 bits and a key of 64 bits. So as we all know, DES deals with a hexadecimal value. So we are inputting the plain text and key in the form of hexadecimal value. So if you want to enter the values of plain text and key manually, you can use the cin method. Cin method usually reads the input from the user. And if you want to allocate, or if you want to uh, initialize the values, you can use the pt is equals to some hexadecimal value and key is equals to some hexadecimal value, so that uh, the value which you are giving will be stored in the following variables. So coming to the key generation part, so we are inputting 64 bits of key, but we only use 56 bits in that. So how do we convert 64 bits from 56 bits? The process is, we are first changing the key value to from hexadecimal to binary value. For that, we are using this hex to bind of key function. So this function usually takes the hexadecimal value as an input and converts into the binary value. So let me show you the function. This is the function string of hex to bind a string of s. So this string of x will be inputting the uh, key value of hexadecimal. Here in this function, we are initializing the numbers from 0 to f with the binary values, so that we'll be using in converting from hexadecimal to binary. So this is a function for hexadecimal to binary conversion. So after converting the key value from hexadecimal to binary, we are making that key to undergo the permutation process, in which the 64 bits are converted into 56 bits. So for that, we are using a key P of 56-bit array, so that we are giving a random 56 numbers which are between 1 to 64. So what usually the use of this array is, we are sending this key P array and binary converted key and value 56 to the permute function, such that it converts a 64 bit to the 56 bits by removing the parity bits. So the idea here is, we converted the 64 bits key, I mean the hexadecimal to the binary conversion. So we'll be getting the 64 bits. So here 57 bit of the key that we are getting, that will be the first value of the output, and the 49th bit will be the second value of the output, and 41st bit will be the third value of the output. In that way, all these 56 bits will be the output of the key. So here the 64 bits are converted into the 56 bits, and we'll be using this key in the further process. So coming to the next step, we'll be dividing the key into two equal halves. That is, we have got 56 bit key, so that we'll be dividing into two halves, RHS and LHS, with each of 28 bits. So as you can see here, we are using a shift table with 16 values, where it has ones and twos, where we'll be using this shift table to perform the left shift operation on the values that to be generated, that to be used in the key generation process. So here we are using another table, another array, key compression, where with it is of 48 bits. So we'll be using this later. So coming to the next step, we are splitting the key into the two equal halves, that is left and right. So left with 0 to 28 bits and right with 28 to 56 bits. So here we are initializing the two vectors, two string vectors, that is RKB, which is for generating round keys in binary, and RK for hexadecimal. So here in the next step, we are performing the shift operation. So we are iterating the for loop from 0 to 16. So why 0 to 16 is that we have 16 rounds in DES. So for each round, we'll be using a sub key generated by that. So in order to generate the keys, we are iterating the for loop from 0 to 16. So left and right. So left undergoes the left shift, where left is a key substring from 0 to 28 bits and shift table of I. So we are taking a shift table value from this. So int of shift table of 16, we are initiated the shift table array with 16 values, where it, so we are taking the first value here, so it is 1. So we are performing the left shift one time, such that we are moving all the digits to the left once by taking the leftmost value to the right one. So this is for the first round of key generation. So in the same way, while iterating the loop for 0 to 16 times, we are generating the 16 subkeys by performing the left shift operation. And the next step is that we are combining the both left half and right half of the key after performing the left shift, such that we are using a string combine, which combines the left and right halves. So yes, now next part is that we are going for the round key generation. So here in the next step, we are generating the round keys. So for that, we are using this array, which is key compression, where we have taken the 48 bits, 48 values. So here, the key after undergoing the permutation will be having 56 bits. So after 56 bits going the compression, it becomes 48 bits. So for that, we are using the permute function, which is similar to the one which I explained before, where here the key of 56-bit undergoes permutation, where for example, if we take this key compression array, here we have 14 as a first value. So 14th bit of the key will be the first bit in the output, and the 17th bit of the key will be the second of the output, and so on. In such way, 56 bits are compressed to 48 bits. Again, we are performing the pushback operations on round key, and again we are converting the binary value to the hexadecimal value, and we are pushing back the value again. So till now, what all we have done is that we have taken a 64-bit key as an input of hexadecimal value. We have changed the hexadecimal into the binary values, and then we have performed a permutation on the 64-bit key value. And after undergoing permutation process, 64 bits are compressed into the 56-bit key, from where we have divided the 56 bits into the two equal halves, 28 and 28. So we have performed the left shift operations to generate a 16 different keys to use for 16 rounds of DES. And the next part is that we are taking a string as an input, a hexadecimal value, a plain text as an input. So this plain text of 64 bits undergoes the same process again, which is to convert the hexadecimal value to the binary value, where we'll be generating a 64 bits. So the 64 bits are again divided. The 64 bits undergoes the permutation process by a standard values of the permutation table, parity bit drop table. So after undergoing the permutation process, the 64-bit plain text is divided into two equal halves, 32-bit and 32-bit. So in the next step, after completing this permutation and division process of a plain text message of 64 bits, so that undergoes a permutation process and division of 32 and 32 bits. So this leftmost and rightmost 32 bits undergoes 16 rounds of DES. So what actually happens in each round of DES? So here each round in DES has the two steps where LN refers to the leftmost bits of each round. Here N specifies the round number. So here R specifies the rightmost bits and N specifies the number of the round. So for example, if we take a look at first round, we'll be having a leftmost 32 bits and rightmost 32 bits, which undergoes the process in each round. So ln, which is L of 1, is calculated as R of 1 minus 1. So L1 is equals to R0 and R1 is equals to L of 1 minus 1, that is 0, L of 0 plus function of R0 comma K1. Here K1 refers to the subkey that we have already generated in the key generation process. So here R1 is equals to L0, which is XORed with the function, where function undergoes the process with R0 and K1. So what actually this function does is, so here to calculate the function, first we need to expand the 32 bits of key into the 48 bits. So for that we'll be using a expansion table, a standard expansion table. So here 32 bits are converted into 48 bits by using the expansion table. So let us take this example. So here 32nd bit of the key will be the first bit of the output. Also in the same way, 32 bits are converted into the 48 bits. And in the next process, the expansion key will be XORed with the sub key that we have generated. So after undergoing the XOR operation with the sub key and the expanded value of rightmost 32 bits, which is 48 bits, will be getting a value. So that is K1 plus E of R0. So this value actually undergoes the function process. So that is now we are calculating S1 of B1, S2 of B2. So what actually this B1, B2 bits are? So as we all know, there are 8 S boxes So each S box contains some random values. Uh, so here, for calculation of each S box value, we have different values of eight such arrays. So let us take an example, S1 box with B1. So B1 here refers to the first 6 bits of the output value, which we have XORed with key and expanded uh, rightmost 48 bits. So those those 6 bits will undergo the process with the S1 box. So here, uh, 0, 1, 1, 0, 0, 0 are the bits of B1. So now take the first, I mean, rightmost value and the leftmost value, that is 0, 0. 0, 0 is basically 0. So this 0 refers to the row number, and the middlemost values, 4 values, refers to the column value. That is 1100 is basically 12. So 0th row and 12th column specifies the value of the S1 B1. So 5 in binary value will be representing 0101. So actually the 6 bits are compressed into the 4 bits. In such way, all the 48 bits are converted into the 32. So in the same way, we'll be doing all the S1 to S8. After calculating S1 B1 to S8 B8, uh, this process continues till 16 rounds. So the value which we obtained in the first round will be the input to the second round, in such a way that we'll be completing 16 rounds of DES process. And after completing the 16 rounds of DES process, the rightmost 32 bits and leftmost 32 bits are undergoing the final permutation process. In final permutation, in the same way, uh, we'll be using a permutation array to permute the values, and a 64-bit cipher text is generated and given as the output. So if we look at the code here, uh, here we are encrypting the message with the encrypt function, and again we are using the plain text to encrypt, and to decrypt we are using the ciphertext which we obtained after encrypting the message. So these are the different functions that we discussed till now. So let me give a brief recap again. So this string hex to bind string of S converts the hexadecimal value to the binary value, and this binary to hex converts the binary value into the hexadecimal. And here permute function, as we have already discussed, will be using a standard permute array of 64 bits or 56 bits, and will be performing a permutation process. So this function helps to obtain the permutation, and we are performing the left shift operations on the key and the inputted plain text. So we'll be using this shift left function for shifting the bits. And we have seen XOR operation in the which is undergoing in all the 16 rounds. So we'll be using XOR function for XOR operation to be performed. And here comes the encrypt function, which takes the plain text as an input and convert and encrypts the plain text into the ciphertext. And we have already seen we'll be XORing the values with S box like S1 and B1. So we'll be having the 8 S boxes with the different values here. So these are the values of S box. And for expansion box, we'll be using a expansion D array with 48 bits. And for permutation process, we'll be using a 32-bit array for permutation process, and we'll be giving this as an input to the permutation function. Um, And for undergoing the final permutation process, we'll be giving a 64-bit array as an input to the permutation function, so that the values which are generated after round key, I mean all the 16 rounds, will be finally permuted with a 64-bit final permutation table. This is all about DES. Thank you.